In today's class, I want to discuss that allocation of the memory in C. So, memory allocation is very important, as I told you that to overcome from the unneeded memory, because to release the unneeded memory, okay, means handling of the memory, that is very managing of the memory is very important in C. Because if a program, as I told you, that program is what combination of so many instructions is called a program, sequence of instructions is called a program, and many programs, collection of many programs is called a software. So there are so many softwares I have briefed, that application software, system software, utility software. So that moment what happens, that allocation of the memory is very important. Otherwise what happens, if any memory is without need, means whatever the memory you have allotted, if that memory is not being used, so that moment what happens, that performance of the program will be slow. Okay, so to get optimization of the memory, means optimization of the program. Optimization means to do function to speed up the program. So releasing of that memory is very important, which is not being used. Okay, so under this memory management, different process I told you, the allocation of the memory. Means allocation means whenever a variable is created in any language, it may be C, C++, Java, Python, any language, whenever variables are created, so automatically some memory will be allotted as per their data type. If it is integer in C, 4 bytes will be automatically allotted. If it is a float, 4 bytes will be allotted. And if it is a double float, 8 bytes will be allotted. For character and boolean, 1 byte of memory will be allotted automatically by C compiler. So that moment what happens, so this allocating of memory is called allocation. Okay, so already I have told you that, but that allocation of the memory depend upon the type of memory. Okay, and as I told, two types of memory is there: static memory and dynamic memory. Static memory is what you know. So I told you that program compilation and execution, I told you that compilation, at the time of compilation whatever the memory is being allowed, that is called a static memory. At the time of compilation, at the time of execution of any program, that time whatever the memory is being allowed, that is called dynamic memory. So that's why on the basis of compilation and execution, memory will be categorized into two types. One is that compilation time memory, compile time memory. Okay, compile time memory allocation, otherwise runtime memory allocation. Okay, so whenever a variable is created, that moment C automatically allocates memory for every variable whenever the program is compiled. Okay, so suppose if 20 students are there, okay, it is an integer array of 20 students, so C compiler automatically allots 20 into 4, 80 bytes of memory automatically. But that moment, if it 20 students is in an integer array having 20 student elements, so 20 into 4 by 80 bytes will be allocated. But that moment what happened, if out of the 20 students, some students are not attending, so suppose 8 students are not attending, that moment 8 into 4, 32 bytes of memory will be wasted. So in this kind, if any memory allotted and that memory is not being used properly, that moment what happens, so ultimately it decreases the performance of the program. Okay, so that unused memory to be released. But in static memory, we have no any control over the static memory to control it. Okay, if any unmemory, yeah, if any unused memory is there, okay, we can't control that because we are not able to change the size of the array. Once array is size is fixed 20, like what you know, so in static memory we will not be able to change the size of the array. So that unnecessary memory will be there, so that will decrease the performance of the program. So because of the program will still run, okay, even though once elements are created, means memory size is fixed. So that moment all that elements are being used or not, it doesn't matter, but memory will be once allotted in static memory, means compilation time. Okay, compile time memory allocation, so that will slow down the performance of the program. So if I want to better control of allocated memory, we need to look back into dynamic memory. Okay, how dynamic memory will be used and how that dynamic memory will be efficiently handled. Okay, as a programmer, we can ensure that how much of memory to be allocated for the data type. Okay, so dynamic memory that mostly will be allocated at the time of program execution, program running. Okay, so that's why allocation of dynamic memory, we can also call this as runtime memory allocation. Unlike static memory, we have full control over how much memory is being used at any time. Okay, we can write a code to determine how much memory we need and that is to be allocated. So we can write a code. Okay, so dynamic memory, it doesn't belong to a variable. Okay, it can only be accessed with pointers. So dynamic memory, it will not belong to a variable. We can access them by point. Dynamic memory can be accessed with pointers. Already we have studied in the previous classes what are pointers. Pointer is in a variable. Point is a variable which will hold the memory address of other variable as a value. Okay, to allocate dynamic memory, we can use two functions, and these two functions are part of your header library, that is stdlib.h. It is a standard library.h header library, and that is to be included to work with two functions, malloc and calloc functions. So these will be used to allocate dynamic memory. Okay, so the malloc and calloc functions allocate some memory, and they will return a pointer to its address. Okay, so malloc and calloc functions, if I want to work with malloc and calloc functions, I need to include a library, that is stdlib.h. Okay, so malloc calloc functions allocate some memory and return a pointer, okay, to its address. So see here, star ptr1 is a pointer, it is integer type pointer. Okay, this pointer, as I told you, that pointer holds the memory address of another variable. So star ptr1 is the pointer. Here malloc function, it has a parameter, one parameter malloc function, as I told you that. So that parameter specify how much of memory to be allocated in bytes. So this malloc function has a parameter, size parameter, so it specifies how much of memory to be allocated, so in bytes. Okay, for this ptr pointer 1. Okay, pointer 1 is pointer. How can we create a pointer? Generally, data type we need to declare, then star and pointer name. Here pointer name is equal to 1, ptr1, ptr2. These two are pointers. Pointers will be created with star. Okay, so int data type to be written, which data type, that pointer created for which data type. So malloc function, it has one parameter. That parameter is called size parameter, and it specifies how much of memory will be allocated in bytes. Calloc function has two parameters. Okay, calloc function have two parameter. One is that amount parameter, size parameter. Amount parameter specifies that how many items are there to allocate the memory. How many elements are there to allocate the memory? Amount parameter specifies how many elements are there for allocation of memory. Size parameter specifies the size of each item, each element, how much of memory to be allocated in bytes. Okay, so the data in the memory allocated by malloc is unpredictable. So data, though the data means it may be integer data, it may be float data, it may be any char data, boolean data. So the data in the memory allocated by malloc function. So I told you that malloc and calloc functions will be used to allocate the dynamic memory. So by the malloc function, memory, whatever the memory allocated by malloc function, in that the data, whatever the data is stored, the data is what? Unpredictable. Why means unpredictable? To avoid unexpected values, make sure to write something into the memory before it. Suppose that if you want to read the data in the memory allocated by malloc function, if you want to read that data, we need to ensure that something to be written into the memory before reading it. If you want to read the data which is stored in the memory allocated by malloc function, it is unpredictable. That's why if you want to read the data stored in memory allocated by malloc function, we need to ensure that something to be written into that memory, okay, to avoid unexpected values. So unlike malloc function, the calloc function, it writes some zeros into all of the allocated memory, because due to that it makes calloc's function slightly less efficient. So, okay, it automatically writes zeros into all of the allocated memory. Okay, calloc function. Okay, so the best way to allocate the right amount of memory for a data type is to use the size of operator. What is the best way to allocate the right amount? How much of memory, right amount of memory for any data type? How much of right amount of data to be allocated? That can be done by use of size of operator. So as I told you that every data type a fixed size of memory automatically allocated by C compiler. So if it is a integer data type variable created, so integer for 4 bytes of data will be 4 bytes of memory will be allocated by C compiler, and for any float data type variable is created, so 4 bytes of memory allotted, and for any double float variable 8 bytes of memory will be allocated. So like that. Okay, so what is the best way to allocate the right amount of memory? Best way that is what by using a size of operator, that is the best way to allocate right amount of correct amount of memory for any data type. Okay, so here int star ptr1, ptr2 ptr1 ptr2 are two pointers. Star will be used to create them. So now ptr1, that variable. So see, for this ptr1 variable, how much of data will be allocated by size of operator we have used here to allocate right amount of memory for any variable. Okay, so malloc size of means what, size of means right amount of data type, right amount of memory that is to be allocated for this pointer. Which pointer? Star ptr1. Ptr1 is the pointer, okay, name of the pointer. So by malloc function we can allocate the right amount of memory for this pointer ptr1. And calloc function has two parameters. One is that first parameter is what? Amount means how many elements are there, and by size of operator how much of memory will be allocated. Okay, so generally what happen, whenever size of operator we are using, so size of operator and the pointer, size of pointer 1, so it tells the C language, C means C compiler, to measure the size of the data at that address. Okay, by the size of operator of pointer 1 means it measures the size of the data at that address. Okay, at that address, because that pointer holds the memory address. At that memory address, how much of data stored, what is the size of the data stored at that memory address. So if we forget this star, so that moment what happens, the size of operator, so if we forget the star, so it measures the size of the pointer. It measures the size of the pointer, not the size of the data at that address. It measures the size of the pointer. So what is the size of a pointer? Okay, it is integer pointer. So generally integer pointer for how many, so it will measure the size of the pointer itself, which is the usually 8 bytes that are needed to store a memory address. So that 8 bytes of memory, 8 bytes, okay, so it measures that 8 byte size of that pointer. Okay, now let us try to understand. Size of operator cannot measure how much dynamic memory allocated. The size of operator cannot measure how much dynamic memory is allocated. So when measuring dynamic memory, it only tells you the size of the data type of the memory. For example, if you reserve space for 5 float values, the size of operator will return 4, which is the number of bytes needed for a single float value. Stack memory.